Okay, so we're going to continue to look at volumes of solids of revolution about either axis, and this time we're going to focus on the y-axis. So the volume of solid of revolution about the y-axis is similar to the x-axis, pretty much, except we're going to have to find an inverse function. All right, and we looked at last time. We had that positive function, and we went around the x. We're going to do the same thing, but go around the y. So what are the rules around the y-axis? So if we've got a y equals f of x, a function, we need it to be 1 to 1, firstly. We'll have a look at what that means in a minute. We also need it to be positive on the interval AB, just like the x-axis. So if that's the case, then the volume of the solid that is obtained when the region of the graph of the inverse function is bounded by f of A, so we put in that A, and f of B is rotated by the y-axis, then the function looks like this, which is extremely similar to what we've got. So let's just have a think about what our conditions are now. So if we've got a function, we need it to be, firstly, we need it to be positive. Okay, so our first example in the last video was y equals x. So that's the case, that's positive there. Now the other function is 1 to 1. So the way we tell if something's 1 to 1 is using the horizontal line test. Horizontal line test. Okay, now what that is if you draw a horizontal line, I'll pick a different color, across here, and it hits just once, that means you're golden, you're all good. But if we've got a function that, something like a parabola, and we draw a horizontal line test through there, you can see we hit twice and we can't do that. All right. So it has to be on the interval. So if the interval is 1 to 1, that's fine. But if it's not, you can't do it. The next thing is you have to find the inverse function, which we'll have a play around with also in a minute. So let's have a look at this example. The graph of y equals ln x on the bounds 1 to e is revolved through 2 pi or 360 degrees about the y-axis. Find the volume of revolution. Okay, so at the moment we've got y equals ln of x. Now, first thing we want to do is we want to work out if that function is 1 to 1. Now, you can graph that, but it's going to look like something like this. Okay, so no matter where you put your line through, it's always going to be 1 to 1. So, like, we can check that first bit off. The next thing we want to do is we want to calculate the inverse, which means we want to get x in terms of y. Okay, so we want to get x by itself. So the first step we want to do is remove the ln. So kind of like a way to think about it is the opposite of ln is e. So if we do e to the power of ln x, and we do the same thing to the other side, this side here, e to the power of ln x, is going to become just the x because they cancel out, and then that's going to be ey. So the inverse function is equal to e of y. All right. Now the next thing we want to do is we want to find out what this 1e is in terms of our y now. So when we'll start anew, so that's our inverse, but when x equals 1, if we sub 1 into here, so ln of 1, you're going to get y equals 0. You can do that on your calculator. And when x equals e, your y is going to be equal to 1. And again, we're just substituting that into here. All right, and you can do that on your calculator. So what we're going to do is we're going to rotate the function around the axis that y belongs to the set 0 to 1. All right, so that's something else we have got to change. If you've got it in terms of x, if we're rotating around the y-axis, we've got to get it in terms of y. So our inverse is e to the y, and our y exists between 0 and 1. what we can do is we can find the volume. The volume of our solid is equal to the integral between 0 and 1 pi lots of our x squared dy. All right, so that's just the general formula. Now we know our x is equal to this, the e to the y, so we can substitute that in as well. So we're going to integrate from 0 to 1 pi lots of, you could bring that at the front as well, e to the y all squared. Make sure we're substituting in for x, but we square the whole thing, dy. All right, so like I said, you can bring the pi at the front, 1 to 0, e of, if you square that, the 2 and the y, the way the power rule works, they go there, dy. Now we're ready to integrate. So if we integrate this, we're going to get pi on the outside. The integral of 2y is half e to the 2y from 0 to 1. All right, which is going to be equal to pi lots of half e to the 2, take away a half e to the 0. All right, so we could leave it in that form, that's fine. Another way of writing it would be noticing there's half in both, so you could have, like, bring that half out the front, so pi on 2, lots of e squared, take 1, and we're going to call that units squared. So there you go. So that's how we revolve our graph around the y-axis. So we've got to look at now the y-axis and the x-axis. So yeah, hopefully we can have a look at some examples now ourselves.